All right, welcome to Weather Watch.
Yeah, welcome everybody to our weather discussion. We're trying to. This is now our. I'm going to just let the cat out of the bag. This is actually our third attempt at this, and the first two were successful. So I hope this one just becomes part of that streak. So if you've never been to the discussion before, what we do is we look at the current weather. We look a little bit at some of the structure and dynamics of what's going on currently, especially if there's something of interest, either locally or somewhere else around the globe. And then we'll take a peek into the future, and we tend to make that a little bit Wisconsin-centric, but with a distributed audience, we can always entertain questions that might come from other locations. So where we're going to begin is with our infrared satellite movie. This is a 12-hour movie. I think I downloaded a 12-hour movie. Actually, it looks more like a 4-hour. I'm sorry, I made a mistake, but you can see it's quite a nice looking image today. If you've been looking at the weather maps over this course of this week, you'll notice that you will have noticed that what we see on the west coast and central part of Mexico, this stream of high clouds and presumably then water vapor beneath them in unusually high amounts, has been emanating from the subtropical eastern Pacific. That hasn't been changed all week. It's looked like this in one way, shape, or form, at least since Monday, because I've been conducting my weather discussions for my 100 class and paying close attention to that. And so the whole central part of the North American continent, especially the southern part of it, the United States, has been flooded all week with unusual tropical moisture, and you're going to see the dew points down along the Gulf Coast of the United States and all the way into northern Mississippi, Alabama, even southern Arkansas, are ranging around 70 degrees, which for March 27th is unusually high. So it's been a moist week in a lot of places. It's rained in some of those places too during the week, but the dew points have stayed high all week long. It's really quite remarkable. So that's one feature of interest that stands out right on this map right away. And you can see that southern Wisconsin is right on the northern fringe of some of the high cloudiness associated with this stream from the subtropics. And it's I wouldn't say that's what's accounted for our cloudiness all week, but it certainly does account for it today. As Pete and I and Michael were talking earlier, we got some breaks this morning for the first time in several days, and that's because we don't really have the low-level stratus anymore. It's more a little bit higher-level cloud that is the predominant type, and that's the kind you can see here in this satellite image. It looks like today. Further to the east, just to the northeast of Newfoundland, Nova Scotia, so over Newfoundland, there's a really nice-looking Canadian maritime cyclone that has a trailing cold front, goes all the way past the latitude of the Bahamas, but well to the east, and then a cloud head in the southern part of the Labrador Sea, and then spilling into southern Greenland. So that's kind of an interesting looking storm. We'll see some other aspects of that when we go through some other weather maps later on. And if you look over the western part of the continental United States, you can see, I think if you pay some attention to the motion of some of these elements in the cloudiness, that there's a fairly substantial, I don't know what happened there, sorry about that. There's a fairly substantial upper trough axis that's probably focused right about over the Bight of California. And we'll see when we look at the upper level charts from 12Z that indeed seems to be the case. That doesn't account really for the stream of high clouds and presumably water vapor from the subtropical eastern Pacific, but it's not unrelated to it. It's not the whole story. Obliquely, along the British Columbia coast, you can see some high clouds as well, and that's tied to a cyclone that's trying to get itself organized in the western part of Canada. And then here on the Manitoba and Ontario border, you can see another disturbance, this one a little bit more well-developed as a comma shape, right in that location, central Ontario, at the end of the movie. That's a decent, well-developed storm as well. And in fact, we're going to see from a couple of different perspectives that the storm that's going to affect us over the weekend and is emanating from this upper trough off of California is the lone southern latitude disturbance in this longitude sector of the globe right now. Everything else is a wave train right across central Canada, and there's a lot of nice evidence for that I hope to be able to show you as we move forward. Okay, so that's what we're seeing across the continental United States and adjacent waters this morning. And one other thing I like to point out is how you can tell what time of year it is, or at least you can tell what time of year it's not. It's not early January, because look what happens in the infrared wavelengths to the high terrain of Mexico, the Isthmus, and the Yucatan, and then also the southern states of the United States. As soon as you spend a few hours in the sunlight, suddenly you get this real incredible darkening of the land, and it's very warm. And in fact, if you look further to the north, you notice that it doesn't get quite as dark, quite as fast. And quite obviously, with a feature of a jet-type feature in between the warm air to the south and the colder air to the north. You can actually even see that in the infrared, which is kind of nice. And you don't really see that at other earlier times in the calendar year. You might see it a little bit later in the year. So, okay, the next thing I wanted to show you was the radar across the country. And given the some of the nice detail we saw in the satellite movie, there's not as much detail in the radar. So not all of those clouds are precipitating. In fact, a very small fraction of them seem to be doing anything in terms of dropping precipitation. So I recall that we had a stream of high clouds coming across western central Mexico and then into the central United States, maybe turning the corner in central Iowa and then heading eastward. And so we see a couple of places only where it's precipitating. This collection of probably weak convective showers, almost like the ones we had around Madison yesterday. And then they are racing across Illinois and into Indiana, and then some of them starting on the Indiana-Ohio border and then into West Virginia by the end of this 6 or so hour movie. Maybe it's 3 hours. And then here is some reflectivity maxima coming up through the panhandle of Texas into central Oklahoma. Those look maybe just slightly more convective, but not well organized, and so quite local and not probably posing much of a threat to any property or lives, luckily. And then a little bit of shower activity off the coast of Texas and southwest coast of Louisiana. Then that's about it. In the central United States, there's a little bit of cloudiness. I think Andrew was telling us that they're expecting some snow in Boulder overnight, maybe even late today. You can begin to see some of the, at least precipitation portion of that development starting to take shape on the Utah-Colorado border. And then some precipitation also into the Puget Sound, Portland, Oregon area. Up to the northwest. But other than that, the rest of the country is precipitation free largely. We might have a sprinkle here. We might have already had it, but we probably won't see any more substantial precipitation until later in the next 24 to 48 hours. And then it will rain fairly heavily, it looks like, and Michael will tell us a little bit about that. And Alex Goldstein's joining us from the island of Manhattan, which doesn't need as many respirators as some of the doctors have said. We found that out this morning. That was nice to find out. But he's going to tell us about the severe weather threat over the south central United States a little bit later. Let's go to the surface map over the continental U.S., and I'll zoom in on a couple of places. First, go up to the northeast. A surprisingly nice day for late March in many of these locations, 57 in Boston, 63 in the city, the second city, New York City. And then it's really warm along the coast with high dew points, 68 at Cape Hatteras, the 61 dew point. Look at this at Wilmington, 77 over 65. That's really getting muggy. Zach Handlos was maybe going to join us today in Atlanta. 70. He's not in Atlanta now, but 75 over 60 down there. We're in our 60 dew point range and high 60s over the whole peninsula. And then if you go a little further to the east, to the west, sorry, Muscle Shoals has a 72, or maybe that's what the hell? It's Mobile. No, I can't remember the name of the city. Anyway, 72 dew point down there, 69 at New Orleans, high 60s, a few 70s here and there. I guess I see just the one in this observation. Is one in the panhandle of Florida. So very soupy air down in the southern states, and nice warm day, 81 over 69 at a couple of these stations. So really nice day down there. And then bone dry, of course, when you go past the escarpment. You have dew points in the 60s in central Texas, and by the time you get to western Texas and eastern New Mexico, dew points are in the low 30s or high 30s and low 40s. And there's, I think, a dry line's been analyzed here in this particular part of the analysis. And the dry line has a wind shift of 90 degrees associated with it. So long ago, we were looking at these things in the aftermath of the Stormfest field project in 1992, and we came to the conclusion that these lee-side troughs very often are, these dry lines very often are set up by lee-side troughs, so they're not entirely distinct features, and that looks like it might be the case today. Here is the organizing disturbance in central Colorado that's threatening Andrew Winters and others of that location with some snow tonight. We'll talk a little bit more about that. And then down over Southern California, nice day, low dew points. In the Pacific Northwest, light rain at almost every reporting station, but nobody's reporting heavy rain on this map. So that's kind of how that all looks across the continent broadly. And then I didn't even mention Madison, did I? Madison's 44 over 39. It's nice to have a dew point that's finally higher than 32, and also a pretty nice day outside comparatively. We've had several gloomy days in a row, and it looks like we have a couple more in the offing. But right now with the filtered sunshine, this is about as best as we've had all week long, and that's pretty good. So I want to point out over northwestern Canada that the fact that even at the surface, there is still very, very cold air in some of these locations. So just to get your, this is Alaska, here's the Yukon Territory, here's the Northwest Territories, and I think that's Great Slave Lake, minus 17 on the coast of Great Slave Lake. The fishing has not begun there yet. So you have to wait a little bit while for that. But the temperatures are freezing. So there's a pocket of really, really cold. Look at this, minus 35 at this location. That's astounding. Minus 29 and snow. Probably, I don't know how many leads there are in the ice up here, but that can't just be lake effect. That's got to be something else because there's probably a lot of ice up there. Minus 29. So still wintry, not really that far away from us. And that will have a role to play in the week to come, the weather for the week to come. And then here's the West Coast satellite movie. I want to just get your bearings for you. The state of Hawaii is, I'm trying to find it exactly on this map. I think I took the right one. I don't see the outline. Anyway, I've got I'm sure it's down in this cloudiness region. I just can't see it through the clouds in the animation. But Hawaii's about here. And then here's our stream of subtropical moisture. In the prior image, it appeared to be just coming from the eastern subtropical Pacific, but it's pretty clear that there's a stream that comes right across the central Pacific and then feeds into that. So that's a nice picture in this, enhanced convective activity at about the date line. Is it the date line? No, it's a little bit to the east of the east of the date line. Is maybe part and parcel of that stream of moisture. And then we don't see very much activity at all in the eastern Pacific in terms of well-developed weather systems. That's been the case all week. In fact, we had our Monday afternoon discussion. It was very prominently absent. The eastern Pacific was absent of any organized weather systems, but everywhere from about the date line to the west was a lot more active. Today, even to the west of the date line, it's not, at least in these few longitudes, it's not particularly active even there. So things have kind of died down in terms of activity in the Pacific. And we were talking earlier on Monday about how sorry about this, I'm not sure what happened, how the jet had retracted rather substantially across the Pacific and almost hadn't really gotten off the coast of Japan. So quite an interesting jet retraction event earlier this week. Maybe it's now coming back. So let's take a look at some upper level observations next. I'll start at 500 millibars with the GFS analysis. This is from this morning at 7 o'clock. And you can see a couple of features of interest. One is this very sharp upper trough that's right over Southern California, just about on the border between the state and the Baja. And it's fairly cold air at upper levels. It's colder than minus 25 in this region here where the cursor is. And this is a very sharply curved flow. And so not surprisingly, we're seeing the beginnings of development just downstream of that, kind of broadly over the Four Corners area, but maybe most prominently in the observations over Colorado. And so that's going to be the beginnings of a fairly substantial weather system over the Central Plains, well, first over the Intermountain West and then the Central Plains, especially for us late in the day tomorrow, it looks like. And then the second feature that caught my eye was this fairly intense baroclinic zone right along the British Columbia, Alaska, Yukon border. And it's a really substantial. Look at how cold it is at 500 millibars, minus 49 degrees. This pocket here is all minus 45 or colder. And that's about as cold as it ever gets at this level, at least over Canada. So this is really chilly air, maybe the last, the last bit of the really cold polar air from the wintertime is going to be involved in our weather over the next several days. And here's the first manifestation of that involvement, a fairly sharp upper trough along the northwest coast of North America. And it's not really characterized by any obvious region of cold or warm advection. It's almost zero temperature advection at the moment, at least as captured by these obs. I'm going to keep my eye on that as the week goes on and see what happens to the temperature advection, because that will either amplify or de-amplify the waviness in the flow and therefore the cyclogenetic potency downstream in time and space. Here's another wave right to the north of Lake Winnipeg, and that's tied to the cyclone that I think we saw over the Manitoba-Ontario border. And so that's a wave number 2. This is 1. This one's here 1. This is 2. And then wave number 3 with the storm over, it's over here, over maritime Canada. So that gives you an indication of a fairly far northward storm track, 3 straight disturbances in a row with equal spacing. We'll see that manifest in a couple of other analyses. And then here's the lone wolf well to the south. It's the only disturbance in this longitude sector that's that far south. And then a big kind of flat ridge over the eastern 2/3 of the United States at 500 millibars. Okay, I want to take a look at the 300 millibar level to get an idea where the wind speed maxima are. And so perhaps not surprisingly, there's a wind speed max off the coast at 300 millibars. I don't want that. And then a sharp maximum kind of over New York State, Pennsylvania border, and Lake Erie. And that's the broad flat ridge that we're just talking about at 500. Further to the north is a sharp jet streak in that northwesterly flow that is tied to that region of strong baroclinicity. Whether or not that develops into a substantial upper feature or not is still yet to be seen. And then here's the rest of the wave train with the polar jet kind of tied along it. And here's our upper trough off the coast of California. The southern and southeastern sides of that are the subtropical jet, it looks like. Let's verify that by going up to 200 millibars, at which level you barely see any of that waving the jet structure in that same location along the British Columbia coast. It's weaker than it was at 300, and yet the jet speeds over the Pacific, the Eastern Pacific, and then over Central North America are at least just as strong over Central North America and much stronger over the Eastern Pacific. So this is clearly a subtropical jet stream feature that's kind of coming in from the central part of the Pacific up through northwestern Mexico and then ridging across the central United States. And this will become the sort of the norm for the rest of the year. And in fact, it'll move further north as the summer progresses, maybe without so much of a tail from the maritime part of the domain here, but it will certainly bulge northward, the subtropical jet, as the winter moves on. The summer comes in, I mean. And then let's go to 850 to get an idea of the baroclinicity in the lower troposphere. It's not so easy to see sometimes because so much of this map is below 850 millibars. And so right in the plains, one can see over Kansas and then heading into Iowa and the border of Illinois and Wisconsin, a fairly substantial horizontal temperature contrast. It's 2 degrees in North Platte, Nebraska, and it's plus 13 at Dodge City. So that's a substantial horizontal contrast in temperature. And that's going to be acted upon as the wave that develops in the lower troposphere comes out of the intermountain west. And so I think this is going to fuel some rather substantial lower tropospheric frontogenesis that will in turn fuel the development of some fairly heavy precipitation in certain locations in the Central Plains. We may be one of them, although it looks to me like it'll be further to the west of us over South Dakota, parts of Nebraska, and parts of Iowa and Minnesota. But it probably will be in the form of rain. But that's the initial ingredients for things that I think might develop a little bit later on. I want to just show you one other thing before I'm done, and that is, let's take a look at some of the vertical motion diagnostics that are sort of some interest. This is from last night's 0Z run, and this is today at 700 millibars at 12Z. Yellow are regions of 700 millibar ascent, and blue are regions of descent. Every one of the contour intervals is 1 decipascal per second, approximately a centimeter per second of downdraft in blue and updraft in yellow. And then the dotted lines are the 500 to 900 millibar thickness field. And so taking a broad view of this picture, one thing that struck me was the couplets of descent and ascent, descent and ascent, descent and ascent that go along either first western northern Canada and then the northeastern United States. That testifies to that northern storm trek. And these couplets are all one individual storm. And then here's the only one that's kind of well to the south. And you can see the vertical motions are starting to take shape at 12Z over Colorado. And Andrew was reporting to us about some of that. So let's go ahead a little bit, even though I know I'm not really supposed to be doing the forecast. But I just want to point out a couple of things. That first, here's wave number 1. Wave number 2, wave number 3, one can still kind of see a northern storm track, and here's a southern storm track, and you can see the maximum vertical motions, the upward vertical motions, emerging off the high terrain into the Great Plains, and we'll start to see surface development there that's rather dramatic. And then at 36 hours, look at what you see. Clearly a northern storm track, ascent, descent, storm 1, here's another one, here's another one, here's another one. And then this is becoming a really remarkably strong couplet of ascent and descent vertical motion. And so I'm contending with my cat here. I got to convince him that he's not that interested and you're more interested. And so strong ascent right here in central Nebraska. That's where I suspect we're going to see at this time, which will be 12Z on Saturday, the most intense surface cyclone. And so, and here's a strong descent. So it's really starting to look like a nice couplet of vertical motion. We can, and I think that's probably where I'll stop. What I would do if I had more time and I was certain of your interest, it's very hard to talk to just a screen. I don't know if people have fallen asleep, but what you can do is partition this total quasi-geostrophic ascent and descent into a number of different pieces that have different physical origins, and then see whether or not these different origins correspond to various other features that you can see on the weather map. And
Hey, John,
is there or is there not some sort of a broad way to characterize the vertical motions?
John, could you actually do that partitioning, particularly for the maybe 24 to 36 hours in the forecast? I'm curious. You were noting that the likelihood of the significant precipitation being across southern Minnesota or western Minnesota and Nebraska, and that's how the GFS is depicting it. We're going to see in another simulation, another forecast, a slightly different one. I was wondering just what the forcing for ascent was.
Yeah, okay, I'll do it for the 36-hour time. How about that?
Okay, great.
At this time right here. So, and this is all from the GFS 1 degree forecast. So it is forecast information we're looking at. So that was the total quasi-geostrophic vertical motion. Here's the piece that arises from, all across the domain, the piece that arises from considering the long isentrope Q vector and its convergence. So this is the part that does nothing but rotate the baroclinic zones. It doesn't change their intensity, with regard to their magnitude. And you see that the largest piece of that total vertical motion couplet for the storm that's bearing down on us is still captured by the so-called shear-wise vertical motions. So here's the strong ascent from the long isentrope Q convergence. Here's the descent from the divergence. And then you see the storm track is also still well replicated by just this one fraction of the total. The other piece that adds to this to make the total is the transverse vertical motion. So these are pieces that are associated with convergence of the across isentrope. And for this purpose, the dotted thickness lines are like isentropes, the across isentrope convergence of the Q vector. So you see a nice cold frontal circulation, even though the QG system struggles mightily to really represent that well. You get some representation of it here. Here's the ascent band on the warm side, descent band on the cold side. And then here's the warm frontal cloud hit, ascent on the warm side, descent on the cold side. And each one of the storms in the storm track has some similar looking picture to that, although the geometries are all going to be different because of the nature of the structure of each of those storms. So this is, add this together with this, and you get this total. So you can see some of the, it's easy to conclude that the shear-wise component dominates, but it doesn't tell you everything about the weather. Then the shear-wise piece is mostly a function of vorticity advection by the thermal wind, although not entirely. And you can therefore split that piece into shear vorticity advection and curvature vorticity advection. Here's the shear vorticity advection at 36 hours. Exactly the same maximum spot, but not as same intensity, and the same with the minimum. But these are really focused. The ascent maximum in this species is quite focused. One can imagine as a consequence that there's a lot of mass being evacuated in one local spot, and that's going to be really good for cyclogenesis, and then anti-cyclogenesis where the descent's going on. And if you look at the only other piece left, which is the curvature vorticity advection, much broader scale. And so we have, but the center is in about the same spot, just next to Michael's hometown of Omaha. And so we have a broad ascent max and a broader descent max. Yes, you're welcome. And then you see also that the curvature seems to be dominating the distribution of vertical motions associated with the wave train to the north. So one can, as I've said many times at the discussion, I'm interested in this because I think there's probably differences between types of storms and the types of forcing that drive them. And we haven't been able to systematically really get that work done yet, but it's certainly something that I think would be really interesting to do. And we have the tools to do it. So that's what it looks like is going to happen here at about 36 hours, 12Z on Saturday, because it's an old run. But 12Z Saturday is when this storm's really taking shape in the plains. And here's some of the, information under the hood. So that's what I have. And I guess we'll go next to Alex.
Oh, no, I'll start off and then I'll send it over to Alex. So if you want to release that screen, I can.
Yeah. Okay, I'm done.
Okay, and let me connect. Hopefully this will work. Surface. Just a moment. Should be coming up in a second. Okay, so we're going to start off looking at the MM5 run from this morning. As always, we start off with the meteorogram, and this is one of the more exciting ones that we're going to look at. John loves that term, meteorogram. You can see temperatures basically through the period, through the weekend, the next 60 hours from 12Z today through the end of the period, 0Z on Monday, so 0Z Sunday evening. We see the temperatures simply relatively constant, and you don't see a significant diurnal cycle, perhaps dampened by the fact that we have cloudiness and some precipitation. Dew points get rather high, getting approaching 10 degrees Celsius, some of the highest dew points we've seen perhaps this year. And you'll see the accumulated precipitation, which is the green line, goes off the charts. So this is truly an off-the-charts event for this particular model run. And the red line is the precipitation rate, inches per 3 hours, plotted down here with the red line. So you can see there's considerable precipitation, well over an inch expected from this particular model run. And it's going to be associated with the cyclone that John was talking about. In fact, if we first go to just the total accumulated precipitation over 60 hours in the forecast, and I'll blow this up a bit, you can see across parts of southwestern Wisconsin, just to the south of Green Bay, there's going to be a strip of, at least within the MM5 forecast, of upwards of 2 to 3 inches of liquid precipitation over us. And you'll notice that there's a dearth of precipitation back across western and northwestern parts of Minnesota, which is really interesting. And I just want to point this out because this is different than some of the other NOAA model runs today. This was a model run that was initialized, I believe, using the GFS, but it has an entirely different solution. What are the factors coming together? Well, first I want to step through the potential vorticity in the lower troposphere. I'll start off at the 0 hour time, 12Z. And the upper trough that John had alluded to before, you can see it positioned well off the west coast of the, or off the southwest coast of the United States, up near the Bight of California. The upper trough is located, and you can see its structure, that broad southwesterly flow of air ahead of the trough makes it for a pretty potent trough at this point. And over much of the continental United States, east of the Rocky Mountains, a broad anticyclonic circulation over us at this point. If we step ahead 6 hours into the forecast, we can see the progress of the upper trough eastward as it moves into the approaching the Four Corners area of the United States, through Utah and western Arizona. We can see the trough axis extends, again, that broad west or southwesterly flow ahead of the upper trough. And recall, this was this is going to be approaching a region of enhanced baroclinicity at the surface, which is going to be an ideal setup for cyclogenesis.
Hey, Michael, is it possible to zoom those maps in a little bit? They're pretty small.
Okay, we'll do. We'll do. Thanks. Oops, don't want to delete. Cancel. All right. Once we move into later into the forecast, you can see this upper trough continues its eastward progression, but you'll notice something really, really interesting. Over parts of northeastern Colorado, you'll notice that there's a bite taken out of the upper trough as it's moving eastward. Now we're looking at the evolution of PV on roughly the 310 Kelvin isentropic surface in a layer between 305 and 315 K. We know that potential vorticities can serve for adiabatic frictional processes, so for isentropic flow. The fact that we're seeing this PV erosion is an indication that either friction's playing a big role or diabatic heating. And the best bet here is perhaps for diabatic heating as we get those significant precipitation rates as this upper trough crosses over the Rockies. And so we'll see that there's considerable evidence for precipitation occurring. But just look as we go further ahead in the forecast, through 18 hours in the forecast, how that takes a significant bite out of the flow. I'll go back. Let me zoom in.
That's awesome.
You can see that, this was a nice sort of upper trough. It was already a bit cut off, but you can see that its progression eastward is being halted, sort of stymied by some process that's going on. You can see the winds beginning to adjust around it as well. And maybe this is some evidence of a self-development type of mechanism. I'll go back just 12 hours earlier, zoom in again so you can see it. Notice how the winds have changed. As the cutoff begins to form, we see the winds adjusting to that. Here, the flow looks like it's out of the southwest, so if everything were nice and conserved, this would be advected right across the mountains and continue on, but you notice that we're getting an erosion of potential vorticity on the eastward side of this trough. If I go to an animation, and hopefully I can make this larger, I can, we'll watch as that trough crosses over, and you can see the erosion. It kind of cuts off and then kind of mixes out over time as it continues its progression eastward. So you can see a nice progression with some evidence of diabatic heating. The upper trough's approaching a region of enhanced baroclinicity. We saw the 850 millibar maps earlier across parts of Iowa and Kansas. We see the enhanced baroclinicity, okay, as we have temperatures that are going from around 6C down to temperatures approaching 18C over parts of Oklahoma and southwestern Missouri. So we have a really intense baroclinic zone. That's at the initial time. If we go ahead to 12 hours in the forecast, as the upper trough is beginning to approach, we see the formation at 850 millibars of a nice cyclone right over the southeastern Colorado, broad circulation associated with it along that baroclinic zone. We also see extending to the east, and I'll make these larger so you can see it. Over us, we're in a southwesterly flow. We can see that there is some evidence of frontogenesis, even along over our area, with these southerly winds or east-southeasterly winds weakening as they move over the colder air. So that's going to be frontogenesis, a band of frontogenesis setting up just to our south. That baroclinicity goes all the way back to the cyclone located over eastern and Colorado. We go ahead another 6 hours into the forecast. Really nice cyclone begins to take shape this evening over eastern Colorado. I'll zoom it up again, sorry. Again, you can see really intense warm advection just along, to the south of us, with the winds becoming more easterly on the cold side of that front. So there's confluent frontogenesis as well as, confluent frontogenesis there, as well as some enhanced warm advection located just to our south. And so this localized warm advection would certainly be indicative of a heavy precipitation event. But the really interesting thing is going to be as this cyclone begins to emerge out into the plains and it begins to wrap up. And I'm going to go just a couple map times ahead at 850 millibars. We'll go to tomorrow afternoon. The MM5 model run has the 850 low over northeastern Kansas, a second geostrophic vorticity maxima over parts of northeastern Iowa, and significant warm advection over us at this point. Cold advection back on the northern side of this particular developing cyclone. What about the precipitation? We talked about that and how it was eroding. Well, first, let's do an animation of 850 so you can get a sense of how the cyclone wraps up quite nicely as it moves northeast into southern Canada at the end of the forecast period. Wish I could slow this down a bit, but can't with the tools I have in front of me right now. But you can see that cyclone wrapping up nicely. Sort of a classic sort of lee side development as the upper trough approaches over the baroclinic zone.
Michael,
Yeah.
I don't think we're getting every frame on that animation. It's kind of jumping through. So
Okay, so I'll just step it then. If we go to again initial conditions in the model forecast, you can see the thickness pattern over the United States at 12Z this morning. I'm just going to jump ahead to 12 hours into the forecast. You can begin to see where that precipitation is occurring. And this is just about in the area where we saw the erosion of potential vorticity as that upper trough was passing eastward. If we go ahead another 6 hours, and I'll blow this up again. My apologies for not zooming in. Again, that heavy precip that you see over parts of northeastern and central Colorado, that's in just the right location for us to expect to see an erosion of the upper trough. And so that fills in really nicely with that. You can see over us. Yeah,
in that erosion, Michael, that produces that hole in the PV field, which means that the upstream southwesterly flow suddenly is producing strong PVA over northeastern Colorado, and that's where the development hangs in.
Right.
So interesting.
Yeah, and so and so as you begin to cut it off, you can see that thermal ridge developing from Kansas, western Oklahoma, and Kansas all the way back into eastern Colorado. Very nice thermal ridge that shows up there. So it shows, and that's that QS, the long isentrope component of the Q vectors, the convergence. That's what's causing that convergence there. The upper trough interacting with those isotherms in the lower troposphere. So beautiful development with that. With again, you can see this trough that extends to the east of it across southern parts of Kansas. We go ahead another 12 hours. or 6 hours, excuse me. Cyclone kind of slides to the east. Still not quite wrapped up. This is at tomorrow morning. We're having a really intense cyclone to our south. Again, a band of heavy precipitation well to our south. Rainfall over us. Remember, we're getting rain throughout much of the day tomorrow, starting tonight. And then I imagine a lot of precipitation to the northwest of the cyclone in parts of western Nebraska, southeast Wyoming, just to the east of Cheyenne, and then the northern plain, the northern Colorado. They're going to be getting hammered with heavy snow and strong winds. So they may have some winter storm watches or warnings. We can check that out in just a moment. And the cyclone moves into the plains. You can see it's beginning its development. This is 18Z tomorrow, and I'll make this larger so you can see it. 996 with the precipitation. Again, the heavy precipitation to the northwest side of this and west side of the cyclone. It's at 996, and then we'll get to tomorrow evening. Cyclone has continued to develop. It hasn't deepened significantly much more at this point, at least in this forecast. With heavy rain, looks like it's beginning to move back in tomorrow evening. But you'll notice most of the precipitation is to our south. But this structure, yeah, John?
To me, this looks like the first time when it starts to really emerge from the plains and start to take on something like a basic canonical structure. It's really struggled to figure out the structure until now. And I wonder if this isn't the time when it starts to develop.
Right. Even after there was some modest development over Colorado, but it really took its time over the plains to kind of wrap up and get more. What's the word I'm looking for? More everything sort of bombing together, for lack of a better word.
It's more phased. I mean, the thermal field's not in phase all the time in the immediate lee of the Rockies with the mass field, and it starts to get better phased when it gets out to the east. Yeah.
Exactly. And then the next, the last pattern on this, you can see this looks more like a mid-latitude cyclone that everyone likes, but they're a dime a dozen anyway, John. There it is, moving toward Milwaukee with, well-developed. We'll see a nice front that's associated with this cyclone. I want to quickly switch gears, go to pivotal for just a second. This should take a moment. I showed you the total precipitation through 60 hours from the from the MM5 solution. Just take a quick look at this precipitation distribution. Very different. The heaviest precipitation well to our west. We have a pretty decent amount, close to an inch of precipitation. That's certainly much less than what the MM5 was producing. And then this band of heavy precipitation well to our south. I would say that the NAM is a little closer. It's somewhere in between the GFS and the MM5 forecast. So the precipitation structure isn't, it's a little bit different. We get much less than what was seen in the forecast. If we go to the, some of those map times, intermediate map times that we're looking at, the GFS already has a well-developed storm in the plain. That looks like more of a canonical structure. 24 hours. We go ahead to 30 hours in the forecast, and it just continues to develop. And so it's a much deeper storm in this particular model. A couple of interesting things. You look at the map. I'll show you the surface map, and then I'll turn this over to Alex to talk a little bit about what we're seeing from the forecast. Again, we're seeing strong easterly winds ahead of a developing warm front. But if you go up further up in the lower troposphere, go to 850 millibars, you'll see that the winds, there's a significant veering profile that's associated with this developing storm. And the winds are now back out of the southwest. And final thing, I keep saying final, but looking at the surface map as this cyclone begins to develop, I'm going to first look at the temperature map. And I'm going to go ahead to a little bit later, 36 hours. This is tomorrow evening. See a couple of interesting things. A really strong baroclinic zone that extends from southwestern Wisconsin, almost due south into across Arkansas. And if you look at the winds, you'll see a nice wind shift associated with that. Sorry, the wind shift. There's no wind shift associated with that so much. There's a little bit of confluence there. The more striking wind shift is back across the southern plains and central plains. If you look at the dew point profile, you'll see that where this dew point lines up is also where we saw some of the warmest temperatures line up, but the cold advection really doesn't start, the significant cold advection doesn't start until you get further back in the plains. And so this is back through here. So there's, maybe this is sort of an extended or a leading dry line, but there is certainly a discontinuity. The temperature and dew point jumps don't occur with a cold front. They seem to be out ahead of it. But this situation is a nice one for severe weather. SPC has a concern for the central part of the United States over the next 24 and 48 hours. This is the SPC outlook for tomorrow. And I'll release the screen so that Alex Goldstein, a graduate of our program, can lead the discussion a little bit further. So just a second, Alex, so I can get out of this. Stop sharing this, and I'll let you begin sharing. So Alex, it's all yours.
Great. Thanks, Michael. Can you guys hear me? You good?
Yeah, we can.
So I just gotta get Chrome up here. All right. So thank you, Michael. Thank you, John. First of all, it's kind of cool to be able to do this again. It's been a while since I've gotten to do the whole Weather Watch thing. So for those of you who are, watching this and get to do this every week, really don't take it for granted. This is really cool. So yeah, let's talk a little bit about the severe weather kind of outbreak that we're looking at tomorrow. And I don't like to use that term lightly. For those of you who know me, and there's a few of you here who do, especially within kind of the storm chasing context, I don't like to use the word outbreak. I think it's got a very particular connotation associated with it. I think tomorrow is an example of a day where it's pretty justified. Storm Prediction Center just updated their outlook, the new day 2. This is their tornado probability. You can see that they've got 15% tornado probability, this red area, and that's overlaid with this hatching area, so that indicates that they're expecting strong tornadoes. So that's EF2 plus tornadoes within 25 miles of a point, anywhere you see that hatched area. So this is a pretty high probability event, and this is especially high probability to see in the day 2 outlook. This is something that the SPC is doing new this year. This is the first time they ever put out these specific tornado, wind, hail probabilities in their day 2. So I think this is probably the first day 2 15% tornado risk that I can remember them actually putting out. So that's kind of exciting. They do use the term severe weather outbreak here. So again, they're kind of on board with this. I think that's a pretty good indication of how serious this situation is. So let's kind of step through what's going on here. So first I'm going to take you up. I want to preface all this by saying that I'm going to use the high resolution rapid refresh model kind of as the basis for this forecast. It's a little bit of a faux pas to look at one model, but just for kind of the sake of succinctness here, I'm going to just do that. You can you've seen other models so far here, and we kind of know that a lot of these are in fairly good agreement when it comes to kind of the synoptic setup that's going on. So the first thing I want to point your kind of attention to here is the 500 millibar flow over the midsection of the country. You can kind of see this closed circulation that's over eastern Nebraska. This, I like to call it a bowling ball that's kind of made its way across the central part of the country. And this is at 21 Z tomorrow. So really, really intense wind field. We're talking on the order of about 100 knots over central Missouri, making its way into Illinois tomorrow by 21Z. Let's step forward another 3 hours, you can see that this wind field just kind of advects its way east, and now much of Illinois is covered by a southwest 500 millibar wind at about 80 knots. So that is a very substantial mid-level jet, and that, to me, is kind of what's going to kick off this entire thing. So if we step down a little bit to 700 millibars, again at 0Z here, actually let's jump back to 21Z. You'll see something that I think is just astoundingly anomalous here. We've got a 65 to 70 knot 700 millibar jet out of the southwest that's underneath this 500 millibar jet that's about 100 knots. So the 500 to 700 shear here is just absurd. This is really pretty unheard of. I can't remember too many instances where I've seen something like this. And if we step even further to 850, you'll see this nice closed low, again, that Michael kind of talked a little bit about. The wind is, especially over Illinois, it's kind of coming out of the south now, so we've gone from southwest at 500 to south at 850. I'll zoom into this a little bit later. But one thing I kind of want to turn everyone's attention to here, and I'd love for Michael and John, whoever, to jump in here, this entire cyclone actually looks to be kind of occluding by this point. We've kind of got this barotropic structure where it's stacked. So I'll look at 500 here, and this is on top of the 850, and you can see that the circulations are right on top of one another, which I find to be kind of an interesting thing to happen kind of at this point in the life cycle of the storm. And I'm kind of curious if that has to do with this kind of pseudo dryline thing that's off to the east. So we can discuss that in a little bit further detail here in a minute. But if we step down a little bit even further, we'll go to the surface. Again, we've got this pretty potent 987 surface low that's over eastern Nebraska, western Iowa. So again, this entire thing from the surface on up to at least 500 millibars is stacked pretty vertically. So that's kind of an interesting little phenomenon we have here. You can see the secondary. I think this is probably the synoptic cold front stretching back in here somewhere, and you can see the wind shift a little bit out ahead of it here. So let's go ahead and look at this from a thermodynamic perspective in terms of the ingredients for severe weather. The first thing that you want to look at, in my opinion, when you're looking at severe weather is the moisture profile. So these are dew points at 20 Z. This is kind of a convective environment. This is before we have any contamination by any thunderstorms that are actually making their way into this environment. And you can see we've got upper 60s to lower 70s dew points in central Illinois. And as we move north, we get a little bit drier, but we're still well into the mid 60s up to this warm front that's extending from the surface low here from Iowa east into actually Wisconsin. You can see we've got this sort of pseudo dry line that Michael alluded to here. It's kind of this dry line Pacific front wind shift thing, and then the actual synoptic cold front is further back here. So I'm curious, and maybe someone can answer this question for me if you guys know. We've got this warm front that's extending here. We've got this cold front thing extending here. There's clearly an occlusion going on. Is that in part is that in part due to the fact that the whole cyclone is occluding from the top down, or is that what's leading what here? Does anyone have
That's
an
a
idea?
really good question, Alex. You're presenting some really interesting observations of this thing. Makes me more intrigued about it than I was before. This coincides with the time that we were mentioning just before in Michael's discussion, where the thing starts to take on something like a classical structure. Finally, it's shed all of the stuff that's kind of non-classical in the immediate lee of the Rockies. But I'm now beginning to think it hasn't shed them all. And I think you're correct to say that the thing that's leading out front, the wind shift out front, subtle though it is mostly a dry boundary. It's not really a thermal boundary. The thermal boundary is back with that second trough over central Kansas and eastern Nebraska. So I don't know. My sense about occluding storms is that they do tend to occlude from the top down. So when you see the occlusion in the PV, you see this sort of treble clef structure in the PV, that sort of works its way downward to the surface. But I'm not so sure that's the way it always has to work when you have orography and orographic structures kind of contaminating the basic development of the storm. This thing has taken a long time to get rid of that westernmost minimum in sea level pressure, which was a function directly of the diabatic heating in northeastern Colorado. And finally, the main upper dynamics have taken over and sort of settled with development going on much farther east, but I think there's still some residual of that prior structure. So I don't know the answer to your question, but it's a good one.
Yeah, it's a really interesting setup that I don't know how many times I've seen, at least within the context of severe weather. I mean, typically when you see these heavily occluded mid-latitude cyclones, these are the kinds of things you're seeing associated with snow, right? So to see this is surprising to me, and I'd be curious to know if there's some kind of climatology out there that looks at this kind of mid-latitude cyclone as it relates to severe weather. But I also tend to wonder if this leading wind shift boundary, whatever it is, were not there, how that would ultimately impact the evolution of this thing as a whole from the bottom to the top, because that's clearly playing a big role. But that's a whole different discussion for a whole other day. So I'll just get back to kind of the more severe weather stuff. So again, we've got really strong moisture profiles here. Lower 70s, mid 60s dew points into Illinois in March is obscene. It's really pretty astounding. So let me go ahead and show you what this translates to in terms of our instability profile. I'm going to choose surface-based CAPE here. And you can see that we've got CAPEs on the order of 3,800 joules per kilogram in March. And so you're putting that underneath a 100 knot 500 millibar jet, and that's gonna create some problems for you somewhere.
Hey, that's opening day right there.
Yeah.
All right, for another season.
Yeah, I'll tell you, if things were a little different in the world, I would not be sitting here. I'd be closer to you guys. But
Man.
this is quite a setup. This is the kind of setup where I think the Storm Prediction Center thinks very hard at their overnight outlook at putting a high risk out. SPC doesn't make the weather, but they certainly do a good job at predicting it, and I think that this is going to be a pretty high end event. So we've got a lot of instability here. I'm going to go ahead and overlay the instability and the shear profiles. And one thing I want to note here, so we've got your 500 millibar wind is your black barb, your 850 millibar wind is your blue barb, and your red barb is the surface wind. We've got the Cape shaded underneath that. And typically when we think about severe weather, we think about, or we try to think about what's going to be the initiating kind of source of the thunderstorms, right? So typically there's a couple things that can do this. Any kind of boundary is going to be something that's going to create precipitation, create lift that can ultimately lead to precipitation. In this case, we've got a couple boundaries. We've got this pseudo dryline thing, and then we've got this warm front. And I know there's at least a couple of storm chasers in the audience right now, and I know that they're probably thinking the same thing as me, which is Illinois warm front with this much instability is really bad news. And I think it is. If I were a betting man, I'd probably sit myself somewhere in southwest Iowa, or southeast Iowa, excuse me, and just watch the supercells as they parade across the warm front here. But the
What
thing
do you
I
mean by bad news?
Sorry?
You said it's bad news. Illinois warm front, bad news. What is
Bad news as in strong to violent tornadoes are possible, if not probable, along that warm front if a supercell can get itself rooted along it.
Okay.
The instability is just astounding. The shear is just astounding. And the thing that I happen to really like from the perspective of someone who likes severe weather is that the orientation of the boundaries to the shear vector is fairly good in terms of discrete supercell development. So typically you want some kind of degree of orthogonality between your initiating boundary and your shear vector. When you have a shear vector that's oriented parallel to the initiating boundary, that's kind of a recipe for quick linear mode, quick upscale growth. In this particular case, if I were to go ahead and put the 6 kilometer shear vector here, you can see that that shear vector is pretty much out of the west-southwest. And so that's going to be largely orthogonal to both the warm front and the cold front, or whatever this front is. So that to me spells long-lived discrete storms. In addition to that, the storm motions are extremely fast tomorrow, and that's in large part, in fact, it's solely in part, to the fact that we have a 100 millibar 500, or excuse me, 100 not 500 millibar jet that's going to push these things super, super quickly. So that's going to also kind of aid in keeping these storms a little bit more discrete than they might be in a lot of other cases. So overall, this is a pretty potent severe weather event. I'm going to pull up just as an example what the sounding looks like here. I just kind of picked one that I know is in a decent area at 20Z. If this loads, we'll see. Loaded earlier, yeah. So that is that's a pretty frightening sounding. We've got 76-degree surface temperature on top of a 70-degree dew point, a nice little dry punch here at about 850. We're talking 3,900 joules of surface-based CAPE, 251 joules of storm relative helicity. So storm relative helicity, and that's in the 1 kilometer layer, the lowest kilometer. So storm relative helicity is streamwise vorticity effectively. It's just the vorticity that's oriented along the flow vector, or it's along the motion vector. So it's the vorticity component that's most easily ingested into the storm. So if a storm has a lot of storm relative helicity to work with, it means that it can easily ingest that vorticity into it and start to spin itself. And so you'll see that within the 1 kilometer layer, that's the lowest kilometer in the atmosphere, we have 251 meters squared per second, squared joules per kilogram, however you want to say it, of storm relative helicity. In the effective inflow layer, so that's basically just a kind of a dynamic layer that has to do with the inflow into the storm. It's 252, so right about the same thing. The storm motion for a right-moving storm is 50 knots, so we're talking what, 55 miles an hour. So if you were to chase this, you would be you'd be struggling to keep up. But overall, this is a really pretty potent setup. So one last thing I'll show. I know I've kind of blitzed through this. we're going to look at the reflectivity. So the reflectivity is this is basically the modeled radar that we can expect to see. This is a little bit of a dangerous parameter to look at if you're not looking at it in tandem with everything else we just went through. This is something that a lot of storm chasers kind of fall into the trap of. People just kind of view this as the truth, and so this says let's just go to Western Illinois and sit there and wait. And at 20 we'll get a storm that pops up. So you can see that isolated, discrete storms are occurring kind of on this arcing boundary here, central Iowa into Western Illinois. And as we step forward another hour, you'll see that these storms have really robustly developed in Western Illinois. These little tracks you see behind them are called updraft helicity swaths, where an updraft helicity swath is effectively, the model is saying that over the last hour is where there's been rotation. So you can see that these storms have strong rotation. They're moving very quickly. These swaths are very, very long. So that means that an hour ago, this storm was down here, and it made its way all the way to here in an hour. So we're talking quick. We step forward another hour. There's just a broken line of discrete supercells, and then another line behind it, which is pretty concerning. We can keep stepping forward, and so by 36 hours, this is at 0Z tomorrow, we have a potentially tornadic supercell heading into the Chicago metro. So that is something to definitely watch out for. If we were to look at the updraft helicity swaths for the entire run, you'll see that we have a long track supercell. This is the last 36 hours in this model's depiction of the world of updraft helicity. Actually, let's do 3 hours. We can filter out some of this. You'll see we had a significant long track supercell from west central Illinois all the way up into Chicagoland. Another one in eastern Iowa makes its way towards La Crosse. Now, there's a little bit more danger in looking at these things. Updraft helicity doesn't necessarily mean you have a tornado. It just means that there is rotation within the model pertaining to a particular storm. So this doesn't say anything about whether or not the storm was rooted within the boundary layer. It doesn't say anything about where that rotation is necessarily focused. This is in the 2 to 5 kilometer above ground layer level, so it might not ever make its way to the surface. But if you see a line of updraft helicity swaths like this, it's something you pay attention to. So all in all, I think tomorrow looks like it has a lot of potential for a significant severe weather outbreak. Tornadoes are, I'd almost say likely, assuming we don't see anything along the lines of destructive interference amongst different storms. There's a couple of flies in the ointment. I don't think they're huge flies right now. One of them is that hodograph in some spots are a little bit straighter than you'd like to see if you're looking at a significant tornado outbreak, and that kind of indicates splitting supercell potential. That's not overall a huge concern of mine. The other one is that there's a parameter called critical angle, which is effectively the angle at which vorticity is ingested into a storm. If you want a critical angle around 90 degrees, that indicates that most of the vorticity that's being ingested into the storm is streamwise. Again, it's effectively helicity. Something around 45 degrees indicates that it's mostly crosswise vorticity, so that's vorticity oriented orthogonally to the path of the storm effectively. So that's not as good for tornado development. So some critical angles on some soundings are a little small, but we're nitpicking a little bit at that point. Overall, tomorrow looks pretty potent. So that's kind of all I have. Yeah.
That was great.
Yeah, excellent.
Yeah.
Excellent. Thank you very much for a really thorough discussion on the storm. I think one of the interesting issues that's not really directly weather related, but it is about this hazard, is with considerable focus in the last several days, rightly so, on this COVID-19 outbreak. I'm wondering how many people are going to be focused on weather versus this the disease, and the spread of it, and how people are going to be alerted. Are they going to be paying attention to TV news? Are they going to turn it off because they don't want to hear about it and they want to watch a favorite movie or a series or something on Netflix and not be tuned into real time into connected to weather reports and things of that sort? So something just to watch out for. And if you have friends that live in Northern Illinois, maybe giving them a heads up on this.
I think it's a good idea.
But following this particular event, I know we're just about out of time. it looks like we're going to transition into a rather quiet period. It'll be cooling off, and I can quickly bring up the one last set of frames here. We're not going to go well out into the future, but you can see that cyclone that's gotten wrapped up over us. Notice the GFS also gives us a period of time when we're not expecting much in the way of precipitation. And so, is this just showing up for you?
Yep.
Yeah.
Yes.
Okay. And as we just step forward in this 48 hours, this is Sunday, maybe some rain showers coming in through the day on Sunday, and then we begin to clear out, and winds turn back to the northwest, and we cool off. And so rain or snow shower mix depending on the time of day, but it's really going to be a mild and quiet weather pattern as we go ahead into early next week. So some really exciting weather this weekend, and really warm and humid air just to our south with some severe weather. We're going to get some rain. The question is going to be how much. We haven't had much time to focus on just the overall amounts, but they're going to range anywhere from probably about half an inch to maybe inch and a half or so possible.
Man,
over
it's a
the
lot.
next 24 hours. So flooding may be also an issue that's going to come up. And then just looking further ahead without looking at forecast maps, we can look at the CPC outlooks for the next 6 to 10 days. Unfortunately, we stay in a cool pattern.
Yeah.
And during that same period, it's dry though, so that's actually some solace there. And then in the 2-week outlook, remaining cool and dry. And then for the month ahead, we actually looks like we do flip a switch and go above normal and maybe begin to get somewhat wet. And we'll have to watch what the trends are beyond that period, because planting season's coming up. We have a whole set of issues with getting crops in the field. We had that last year with a really wet spring. Hopefully farmers can get their crops in, and then we have to deal with issues on food supply as we get into the fall. Hopefully people can be available to help with the collection of those crops once they've matured. Anyway, thank you, John and Alex and Pete, for setting this up, and everyone that's participated in this today, the viewers and the questions that have come up in the comments. And have a wonderful weekend. Stay safe and stay well.
Yeah,
Thank you,
thanks
Mike.
everybody.
Thank you, Alex.
Yeah.
I'm going to stop the recording. If anybody else, I'll leave this open for a while, so if anybody else wants to just hang around and talk about whatever. I was in a class the other day, and Dan went through all the students and just checked in with how they're doing, and it was good to see everybody. So if anybody wants to unmute their video and just hang around and talk, I'll stick around for a little bit. So otherwise, have a good weekend, everybody. We'll do it again next week.
Yeah.
Thanks,
Thanks
Pete.
again, Pete.